Production support for Hot and Cold is brought to you by American Solar Technics, manufacturers of components for wood burning and solar heating systems. Hey, I'm Tom Gozy. This week on Hot and Cold, would you believe it? We're in the basement again. Everything starts in the basement and works its way up, doesn't it? Floats to the surface. There's some kind of joke somewhere, but I'm sick of giving old jokes. Stay with us. We're going to do more wiring this week. Whole new stuff. We'll be right back. Here we are in the basement again, and I think the last time we were here, none of this was actually operational, and it is now. We've got a piece of Romex coming in here, feeding from our old panel into a 20 amp breaker. Feeds both of the bus bars because we're going into a double breaker. And I've already got 7 circuits wired up. I've got basement lights, I've got upstairs lights, I've got outlets all over the place, and I haven't put the cover on yet, so I can't label anything, but I'm labeling each wire. We have basement outlets here, and this one I have not wired. This is the kitchen lights. We'll wire that in a little while. And we're rapidly getting to a point where we're ready to have the electrician come in. Electrician's coming in the next day or so. We're going to put a new meter trim on the house and bring it into this panel, and we'll disable the old panel completely. We're putting a new meter trim on for a couple of reasons. One is I made a terrible, stupid mistake in that I put a wire into a screw into the big wire that feeds the other panel, and I'll show you more when we take that out and we diagnose what happened. But fortunately, I didn't burn down the house, but you'll see that next week. I think we'll have that wire out. We're going to look at it very closely. Could have been a real catastrophe. Turns out it wasn't. So rather than wait later, we're doing that now to get that issue solved. But the real reason we wanted to move the meter trim was on the front of the house, and there's this big wire that comes down the front of the house, goes to the meter, and then it goes under the meter, and it just looks stupid. It's a small house, so it really kind of compromises the way the front looks. We're moving it to the side of the house where it'll be out of sight of the front, and it'll look a lot nicer. So, and of course, with all this done over here, everything will be a lot more convenient, much neater. Everything is newly wired. There was one circuit that we were thinking about leaving, which was overhead lights, which was, I don't have any of it down here. Actually, let's go over here. I'll show you the other end of it. An old shielded cable. Actually, probably was fairly safe, but I get into this and I look at it and I see old cloth insulation that's kind of raggedy. So, like, as an example, if you do this to it, if you bend it, it tends to just break. So the insulation is breaking. See there? Well, you can't really see it, but there it is. It just pulls right apart. So and you know, it's probably okay if you're not doing this to the cable, which nobody is. But I said, you know, let's replace it. So we had one circuit that was overhead lights upstairs, overhead lights downstairs, overhead lights in the kitchen, and an outlet. So I said, let's get this out. Took it out, and it's gone, and we rewired it with all new 12-gauge Romex cable. So that's all done. That was the last circuit that had any of that material, the shielded cable. So that's all gone, and everything else, pretty much everything else, will be new, or it'll be fairly recent Romex cable that's been here for a while, or is already in place. We've got a bunch of lights in the basement like this one here. They're spread all around, so now when we flip a switch upstairs, Whole basement is illuminated, including the dark recesses over way back over there. And then we also put electrical outlets too, like this one here. Cover plate's not quite even, but that's okay. So we got outlets, so we have minimal extension cords if we're doing any work in the basement, which, you know, could happen from time to time. So as I say, we've got 7 circuits down here now. We will have some more, and when the electrician comes to do the service drop, put the new meter trim in, I'll swap over the big stuff that's still over there, which would be the electric stove, the clothes dryer, and a couple of other small circuits, and then everything will be over here. So, excuse me, what we need to do is go upstairs and we'll look at some of the wiring that we've been doing, and we got a little project we're going to accomplish. First floor wiring is pretty simple because we go up like over here. We can go up into the sill diagonally and wind up in the wall where we're trying to get the wires. So if I go up at a 45-degree angle about midway in this sill, the drill comes out inside the wall cavity, and I can feel that because I'm no longer drilling through wood. And then if I mark where I am, I can poke a hole in the wall for the outlet and snake the wire up through. And there's a piece of foam here where there was an old register, so I know right where I am. But other areas where I had solid wood, I have a routine where I was putting a screw down through the floor, because we're going to redo the floors, making sure there's nothing in the way. I'm not going to go into any wires or pipes or anything. And I can know exactly where this goes up, where I want to have an outlet. So we've done that all around the first floor. Very simple in an old house, usually, to get up into the walls and get the wire in place. As a do-it-yourself project, it's a little more complicated in that you don't have all the tools. Professional electricians have special snakes, if you want to call them that, rods that they can get up into the wall and get into weird places that you just can't get into just by pushing a wire up like I have done. And it's much easier to do this with 2 people instead of one. One person down here feeding up and one upstairs receiving the cable goes a lot faster. I did it by myself, so I spent endless times going up and down the stairs, but it can be done. This was not an elaborate project to get this accomplished, to do the first floor. Second floor has a whole other set of circumstances, which we'll talk about in a minute. But we got to take a break here. We'll do that. We'll be right back. Hey, we're back, and we were talking about second floor lights and second floor power. And fortunately, where this is an old house, somebody had run this piece of Romex, it's 14-gauge wire, and it goes up through the floor here and actually goes up to the second floor. So we're going to use this wire to feed our new 12-gauge wire up to the outlets on the second floor. So why don't we work our way upstairs? We've got a couple things to look at before we get to where this is, but let's head up there and we'll take a peek. On the stairs, headed upstairs for a big reason, because we're headed upstairs to do wiring. We already started up here in that we've brought power up. We're behind a wall that we put in by the stairs, and originally where this duct tape is, I had this electrical box because I was limited by the length of wiring. It was too high for what it should be. So what I've been doing is, where I had to rewire anyway, I was able to undo everything that was in this box, which wasn't the original plan, and put the box where it should be located. There's one line down below here that feeds the box, and then there's 3 wires that come out. This is a 3-way switch. This is a piece of 3-conductor 14-gauge wire that controls the upstairs light, so you can turn it on from down here or upstairs. Then we have the living room light, which will be a dining room at some point. That's just a standard switch. And we also have a feed that goes to the kitchen lighting, and also feeds there's a small bedroom up here. So we've got a couple outlets and a small, couple outlets in the bedroom and a single outlet in the hallway. This whole circuit we're going to put on a arc fault interrupter. Arc fault interrupters have to be used in bedrooms by code. And what an arc fault interrupter does is it senses an electrical arc, because many fires start in bedrooms where people have extension cords or low voltage wiring that if for some reason there's a short, the cord wears out or it's hit or whatever, you get this little electric arc, a little spark. It's not enough to trip the circuit breaker downstairs because usually it's a 20 amp breaker. But it's enough to make an electrical spark which could burn the house down, and this usually happens in bedrooms. So what we're going to do is, where this feeds a bedroom, we'll put an arc fault interrupter on it, and there'll be another bedroom upstairs. That circuit I just showed you, that wire, we'll have one on there as well. Why don't we use these in all the circuits in the house? Because they're expensive. They're about $35 a breaker. And the places where most of these kind of mishaps occur are in bedrooms, where there's a lot of wire, low voltage, not low voltage, but small conductor wiring that people run bed frames up against it or whatever. So we will do those two circuits. Let's go up further now, find our way up here, and we got more wiring to look at. Well, you haven't seen much of this room before. This is a big bedroom upstairs. This was attic space at one point that was made into a bedroom, and I've been ripping into it to run wiring. That wire I showed you in the basement, that coiled up piece of 14 gauge wires right here, it was in an outlet that was in the baseboard. It was not done very well, so I've decided that where we had old pine boards on the floor, it's really easy to pull these boards up. And once you pull them up, there's a second layer. In this case, there's 2 layers of boards. And we can really have fun with the second layer of boards because we have 2 layers with joints offset. So it gives me the luxury of doing all kinds of stuff to get wires run. And like this board here, I just cut a little piece out rather than pull up the whole board because I need to get my hand in here to run wires, and that's big enough for me to get my big paw in there to do what I need to do. And this was actually a full board. I cut it off here on the floor joist, and these floor joists are about 32 inches on center. And I opened up a pathway all the way across to allow me to get 3 boxes in here for 3 electrical outlets. We'll do the same thing probably on the other side of the room, and we had an overhead light up there with a piece of the shielded cable, and you can see somebody's got electrical tape on it because that insulation was all busted up. So I decided we weren't going to use those because we could not run new wire. So what we're going to do is come in this. I'm pretty much done here now. We're going to close this up again. Come over to here, lift some boards, get a wire run up into this wall with an outlet here, a wall switch here, and a wall fixture up a little bit higher. And then we've got some lighting for when you walk into the room. You just flip the switch and go about your business. You can have obviously additional lighting on a table or with a floor lamp or whatever. And we'll get going across this way because these floor joists are, what are those? Those are like 4x8s, go all the way across the building. They span about 14 feet, 15 feet. We'll be able to go right across here to get to the other side and run any outlets we want to run. On the front, this is the front wall of the house here. I'm not sure we're going to be able to easily run outlets there or not, but I think if we get 3 here and 3 there, we're in pretty decent shape, and we'll see. I'm still figuring that out, but right now we're going to come up into this first box with our cable to feed here, and then we go from here over to here, and then from here to the end, and that's all roughed in. We can additionally use it. This is a junction to go in this direction, which is the plan. And I stopped because I was running low on wire. You do eat up a lot of wire doing this and adding outlets. Probably could have put 2 here, but I put 3 because I felt like I was compensating for the fact that I'm going to probably have no outlets on this front wall potentially. So having it right near the front wall on the side where I can easily run wires kind of makes sense. So anyway, that's what we're up to up here. We're running everything with 12 gauge wire because we are going to have a fair number of outlets in the circuit, even though we're not going to, bedroom you don't necessarily use very much. So this will be one circuit, this room. It'll have probably about 7 outlets and the overhead light. Go downstairs to an arc fault interrupter, and this is the last wiring project in this house in terms of having to run wire. is doing this. And this is the two-person operation, feeding up through the existing hole, because I want to be very careful that we get one person feeding and one person pulling, and we don't pull the thing apart in the process of sneaking up through the wall, because the holes are very small. And that's something I just want to mention. If you're doing this kind of stuff, you're running a piece of Romex. A piece of Romex is not very big. What is that? Not even a ½ inch and not even a ¼ inch in thickness. I like to use a 1-inch hole, a 1-inch spade bit for running my wire. I was using a smaller one, which was 5/8, and I find if I have to run 2 wires through that, I mean, I'd rather run 2 wires through a hole that big than a hole that big. It makes life a lot easier, because this wire is not the most flexible stuff in the world, and it tends to bind up. We don't want to damage it as we're snaking it up through the old building. So anyway, we could also sneak this up in a closet or build a chase or do something, open up the wall and poke holes every so often to get it snaked up. Again, as a do-it-yourselfer, if you're doing this as a contractor or with a contractor, they have a lot more tricks for doing this kind of stuff, getting it where we need to have it. We need to have a break here, though, because we're going downstairs. We're going to do some low voltage wiring as opposed to what we call high voltage wiring, because low voltage wiring is a real do-it-yourself project that anybody can do. You can't get into too much trouble. And it's good when you can't get into too much trouble, because I find that I get into way too much trouble doing things like this. We'll be right back. So here we are back for our last segment, and we're going to do some low voltage wiring. We're going to replace a thermostat. We're going to replace the replacement thermostat. This is an old thermostat I had here. We had a mercury thermostat, which we disposed of safely. And I put this in temporarily, and I absolutely hate it. So it's coming out and comes off like that. We're going to take it out because it is really hard to, it's a programmable, and we don't need a programmable here. So what we're going to do is take it out, and I just popped the cover off here, and there's 2 wires that go in that control this, that this controls. So we're going to take these 2 wires, we're going to disconnect them, and we've got 2 sheetrock screws that hold this in place. We'll take those out. If you have just a straight ahead heating system like an oil system, usually you're going to have a 2-wire thermostat. And sometimes they're red and green, sometimes they're red and black, sometimes they're black and white. Let's get this off, and I don't want the wires to fall back in the wall. That would be exciting. So there's the old one. We've got a new one here, which is just a real simple thermostat. It is a on-off, no programming thermostat, because nothing is being programmed here anyway. So I glanced at the instructions and figured they're not that complicated, so we're just going to take it out of the box and we're going to go for it. Now, most of these thermostats have a base. We'll spend more time getting it out of the box maybe than we will installing it. Most of these have a separate base, and we will get this off the base here. They snap on. They have big plugs here. So what we do is mount the base first, much the way we did on the other one. We bring the 2 wires through. Now this is low voltage wiring. This is 24-volt wiring, so it's pretty safe in terms of you can't get a shock putting your fingers across it. I'm going to use my cordless drill this time. We want it approximately level. Approximately is good enough for what we're doing here. We are going to have to fill some screw holes because this is all lath plaster walls, so we're going to, we hit wood there. So we have a red and a black. Put the red to the red because that would be, even though these are red and black, put the red there and the white goes here. Is that tight enough? Oh, okay. And we'll sneak the, we'll use the needle nose pliers for this one. We'll sneak it up in there. This wire should be replaced. It's kind of funky, but we can, where it's low voltage, it isn't really, oh, Godfrey. All right, let's twist this. We'll trim the end too while we're at it. Now we'll take our needle nose pliers. Get it up in there. Now I've almost completed this whole operation. All right. Now, most of these thermostats use batteries because they're digital. This takes 2 AA batteries. We're going to put the 2 AA's in, which we've done. And we take that, line it up, push it in place. If we turn it up for warmer, I'm going the wrong way. See it, the temperature's going up. And do I have it on heat? There's a setting here for heat, yeah. And the heat will come on, and all is right with the world. You can't hear it, but the heat is running. And that's all we need to do. So we go up, we go down this way if we want to bring the temperature back down again. I mean, I got it backwards. All right, we go that way. Okay, that's hot, warmer, and that's cooler. I'm all right. I can't do arithmetic anymore, but I can wire a thermostat. So we'll leave it at 69 degrees. That's all there is to it. The room is 71, so I just turned the heat off. And if you have a house, a bigger house, you have a lot of zones like a bedroom zone, and you have areas where you're going to have low occupancy for long periods of time, setback thermostat makes sense. This is an old thermostat. I've had this for about 15 years, and it's a little bit complicated in terms of programming, but it still does work. And I primarily use it just to tell me what the temperature is, and I'll leave that sitting somewhere where I don't have a thermometer. And then when I have a need like this where I have to put something in temporarily, this goes back into service. But in the meantime, it will get used as just a thermometer. When you go to the store to buy one of these, read the box, because some of them are really weird in terms of programming. The longer you can set it back for and the deeper you can set it back for, the better it is when you're using the setback thermostat. If you want just a steady temperature all the time, this little house, a steady temperature makes a lot of sense. I have setback thermostat at my house, and I've set it just to one temperature because I never want to have the temperature vary that much. I guess I set it back, no, excuse me, it sets back a couple degrees at nighttime, but it really isn't even necessary because the heat load is so low. So small houses where the heat load's not very high, it doesn't make sense to do a setback. You might as well just leave it at 68, 69, 70, whatever is comfortable for you, and be done with it, because you tend to waste more energy than you save. Big houses where you have zones where people won't be for maybe 16 hours a day, set it back, you're going to save money. But you want to be able to not have to, it should be the kind of situation where you should be spending an extraordinary amount of money for a setback thermometer. And you have to be careful because some of them are really expensive and they're not going to give you a good bang for the buck for what you're trying to do. It's easy enough for you in the morning when you get up to turn it down, and then when you get home turn it up if you're gone for 16 hours a day. It doesn't cost you anything. If you already have the thermostat, maybe it doesn't make sense to even have a setback device. Again, bigger houses, more multiple zones. You can't go around and set everything down and turn it up again. It might make sense to do that. Make sense? I think so. Anyway, so read the directions. Before you buy them, make sure this is what you want. This was a $10 thermostat, and it's good to use a thermostat like this to replace the old mercury thermostats, which are environmental hazards. And make sure if you do replace this, you find out where you can exchange in the old mercury thermostat. So don't put it in the garbage, whatever you do. Usually the store where you buy the new one will take the old one and make sure it goes to a recycling center. But we are out of time. Now we got myself a whole new thermometer again. Oh man, we're going to have fun now. If you have any questions, give us a call on the radio. We will see you next week. Production support for Hot and Cold is brought to you by American Solar Technics, manufacturers of components for wood burning and solar heating systems.